All right, we're back. We are still on page 4 of notes 20. We're doing areas of regions bounded by curves. The last one we were using our calculator quite a bit. And then as we continued through the problems, we arrived at what I consider the ultimate form of the work, where you define f of x, g of x, you store your bounds, and then you just write this really nice integral. And if you write your integrals this way, you're not going to run into the problem of like, did you correctly distribute the negative? You don't want to get caught not doing that. And if you just define your functions, the calculator does the work for you. You don't have to worry about it. So be careful as you do those. If you get good enough with your calculator, it doesn't cost you time. Like it's not a hard thing to do. All right, let's see. Don't use your calculator. Well, that's annoying. Find the total area of the region bounded by the curve, y equals x radical 4 minus x squared. You can be clever about it to simplify things. Well, I'm looking at the region, I think right away, like I think the area of this is equal to the area of this. Keep in mind, we're doing area, not definite integral. The definite integral of this, I think this is an odd function. So I think the integral from -2 to 2 is just going to be 0, but that's not the question, right? The question is, what's the area? How much paint do you need? So I think what I'm going to do is I'm going to do this part and just double it. So that's my game plan. I'm going to do 2 times the integral from 0 to 2 of x root 4 minus x squared dx. All right. So you got a bunch of choices. You can do u substitution. You can just like go for it. So I'm going to just go for it. So there should have been a -2 here. So a -1/2 here. So -1/2. And now it's like perfect on the inside. So that's like blah to the 1/2. So 3/2, 2/3. And 4 minus x squared to the 3/2. And then go 0 to 2. I'm going to do it a second way too. So this is -2/3. And then when we plug in 2, we get 4 minus 4 is 0 to the 3/2 minus, when we plug in 0, we get 4 to the 3/2. I always get a little nervous, like this coefficient being negative. It's like, uh-oh, something better work out nicely. But then the thing that works out nicely is this is 0. So we get minus, negative, positive. So it's like, oh, okay. So I guess it worked. So the square root of 4 is 2 cubed is 8. So we get -2 times -8 is 16/3. So I think we get 16/3. Let's do it actually using u substitution and changing the bounds. So this is an or. We want 2 going 0 to 2, x root 4 minus x squared dx. All right, so what would we do? We would say u is equal to 4 minus x squared. So then negative 1/2 du is dx. If x is equal to 2, then u is equal to 0. If x is equal to 0, u is equal to 4. So we just straight up make our substitutions. Oh, is there another x somewhere? Yeah, x dx, not. I gotta move some stuff. This should be x dx. Okay, go back and review your u substitutions. If you haven't done a u substitution in a little while, like never get too far from that. So straight substitution, it's going to be 2, pick up a -1/2, and then just bounds go where bounds go, right? 2 gave us 0, 0 gave us 4, so put them in where they went. 0 to 4, it's a little weird. Get u to the 1/2 du. So now what we do is we flip it and change the sign, so it becomes, it was -1, but then we're flipping the bound, so it becomes +1. Then u to the 1/2 du. So +1 times the reciprocal is 2/3 u to the 3/2, 0 to 4, which is going to be 2/3, 4 to the 3/2 minus 0 to the 3/2. Square root of 4 is 2, cubed is 8, times 2 is 16/3. Same answer either way, doesn't make a difference. But just be aware that you can do that. Another option, which I definitely do not want to do, is we could have done each region separately. Do this, do this. It's kind of weird though, because in this region, right? You have a top curve and a bottom curve. The top curve is 0. So we would have done the integral from -2 to 0 of 0 minus x root 4 minus x squared dx plus 0 to 2 of, in this region, the top curve is the whatever thing and the bottom is 0. So x root 4 minus x squared dx. I'm going to give you the same answer, so like better to do the double thing, I think. 16/3 though is our answer. All right, let's tackle this one. Find the area of the region in the first quadrant bounded on the left by the y-axis, okay, below by the curve. Below by, that means that's the floor. So this curve right here is the floor. So it's this. It's the floor of the region. Above by the curve this and this. So those are the ceiling here and here. This region, really unfortunately, is not horizontally simple because the left and right curves switch right here. So left and right curves switch, not horizontally simple. It's not vertically simple either because the top and the bottom curves switch. So you got to do it. You need 2 integrals no matter how you do this. I think it's probably easier to do it in terms of y, strictly because all of these functions look like super, they really look like they want you to integrate with respect to y because they're all like x is a function of y. So let's do that. So we're gonna have 2 separate integrals. I'm gonna split them here. So the first one, we're gonna go from y equals 0 to y equals 1, right? From here to here. And then we gotta do the right-hand curve minus the left-hand curve. So the right-hand curve is 2y to the 1/2, and then the left-hand curve is just 0, dy. And then we will add to that, we're gonna go from y equals 1 to y equals 2. So 1 to 2. And then the right-hand curve is this, which is 3 minus y. And the left-hand curve is this, which is the quantity y minus 1 squared. So it's going to be parentheses 3 minus y minus quantity y minus 1 squared dy. All right, that's going to work. So let's see if we can do it. 3 halves, 2/3, 4/3 y to the 3 halves from 0 to 1 plus, anything good happening here? Not really. 3y minus 1/2 y squared minus 1/3 y minus 1 cubed 1 to 2. Blah. All right, so this is just 4/3 plus. Okay, so when we plug in 2, we get 6 minus 2 minus 1/3 plus, when we plug in 1, we get 3 minus 1/2 gone. That's pretty good. So what do we get? 4/3 plus 6 minus 2 is 4 plus 3 is 7, and then minus 1/3 minus 1/2. Why did I write plus? Boom, boom, boom. I think this is minus. I think I got confused there. Right, when I plug in 1, I should get 3 minus 1. Yeah, so that's wrong. Good eye, me, I guess. So 6 minus 2 is 4 minus 3 is 1. And then negative 1/3 plus 1/2. Negative 2 6 plus 3 6 is 1/6 plus 1/6 is, I don't know, 8/6. 8 plus 6 plus 1 over 6. 14, 15 over 6, which divide by 3, 5 halves. 5 halves? Does that feel right? It feels a little small. 1, 2, I don't know, maybe not. So we could have done it the other way. Let's use a calculator for that. I know it says not to, but let's like check it on a calculator and then also do it a second way on the calculator. Let's find out. So I want the integral of 2y to the 1/2 so y goes from 0 to 1, which is that, and then we want to add to that the integral of 3 minus y minus the quantity, y minus 1 squared, y goes from 1 to 2. That, and if I do this plus this, I get 5/2. Woo! All right, what if we tried to do it the other way? Without really explaining anything. Oh my God, I don't want to do this. All right, hold on. Solve x equals y minus 1 squared. Solve that for y. Okay, so I know that I want the positive one. So I'm going to do integral square root of x plus 1. That's the top curve minus the bottom curve is x squared over 4, I think. So I'm trying to rewrite everything in terms of x, and then comma x goes from 0 to 1. And then I need to add to that. So 3 minus x is on top. Integral 3 minus x. This is, you know, this is probably good for you to like work these things out on your own. X squared over 4 is the bottom again. Comma x goes from 1 to 2. I don't know. I think this is gonna work. 5/2. There you go. That's if you want to do it in terms of x. Take a look at those equations, and if you wanted to do it by x, there you go. I think it was worse because I had to like solve things for y instead of just using what was given. Whatever. You get 5/2 no matter how you do it. So I'm gonna go back to the notes, and then we're done with this page, and we'll be back in the next video to keep going, which you know, you just gotta practice. Don't be afraid of using y. I think when most people are learning calculus, they're afraid of integrating with respect to y, which like makes life so much harder. Just embrace it. It's not that bad. It's right, take away left, and then you go from the bottom to the top. Like it's not more complicated. It's just like your whole life you've been thinking of vertical things. That's why x feels more normal. So anyway, see you in the next one.